Friends, welcome to Model Maths Nagaraju YouTube channel. First, please like, subscribe and click bell button, and also please share with your friends. Now in this session, intermediate second year maths 2A probability. So in this probability, let us see the long questions. Already in part 1, we just have seen state and prove probability on additional probability theorem and also multiplication probability. 2 questions are completed, and third, fourth, 5, 6, 7, these questions depend based on Bayes theorem. So especially for the 2020-21 year students, that syllabus is not in our syllabus. So from 8th question onwards, we can see for this 2020 and 21 years. So remaining also it is useful. So what is the 8th question? Define conditional probability if bag B1 contains 4 white balls, 2 black balls, and bag B2 contains 3 white balls, 4 black balls. A bag is drawn random and chosen at random from it. What is the probability of a ball drawn is white? Okay, before doing this question, first of all, what is define of conditional probability? So let us see what do you mean by conditional probability. Generally, probability means number of favorable outcomes by number of all possible outcomes. So here conditional probability means, suppose if the occurrence of an event for example capital A, occurrence of an event capital A is given that B has already happened. So conditional probability means it depends on 2 events, so one after one. Suppose B is already happened, then what is probability of A? So that is mean by conditional probability. Is it clear? Occurrence of event A and B has already happened. B happened already, and probability of A we are finding. Means we can denote it by A by B. So here which is happening in the first? B is happened. At that time, what is the probability of A? Okay. So this is defined as how can we define? Means it is equal to P of A intersection B by P of B. So here P of B, the denominator must be not equal 0, or we can write greater than 0 also, no problem. Okay, happened. So here item it is denoted by P of A by B, and that is equal P of A intersection by P of B. Similarly, P of B by A also we can write. How can we write? Tell me. Same. Yeah, B intersection A by P of, which is in the denominator A. So P of A is not equal 0, or we can write greater than 0. Of course, P of A intersection B also we write, no problem. Both are represent same meaning. So this is conditional probability. Next to take the question. What is question? Bag B1 contains 4 white and 2 black balls. So I'm just giving in a table bag B1 and B2. There are 2 bags. So in every bag white balls and black color balls. So how many white balls are there in bag 1? Bag B1, 4 white balls, 2 black balls. 4 white balls, 2 black balls. Similarly, bag B2 contains 3 white and 4 black balls. So this is the in table I represented given information. So it is very useful to understand very clearly. So here total 2 plus 4 6, and total bag 2 contains 3 plus 4 7 balls. Okay friends? Yes. So this is given. Now take the question. Here 2 bags are there. First I am going to write the probability of bag 1 and probability of bag B2. Okay, what is probability of bag B1? So probability of bag B1 is P of B1 is equal, simply I am writing 1 by 2. Why? Similarly, probability of bag B2 is P of B2 is equal also 1 by 2. Why? Because of there are only 2 bags. So each bag the probability 50%. So for bag B1 1 by 2, for bag B2 also 1 by 2. Okay, it is clear. Now take the question. Here question depend on which color. A bag is drawn random, chosen at random from it. What is the probability of ball is white. So question depend on white ball. So first white balls in bag B1 there are 4 white balls. So in bag B1 probability of white is 4 by 6. In bag B2 probability of white ball 3 by 7. How can we represent? With the help of conditional probability we can represent. So probability of white from chosen from bag B1, that is probability of, see here first bag is B1, in that bag B1 what is probability of white. So B1 is chosen in the first, then white ball probabilities is equal. So in bag B1 how many white balls? 4 balls. So total balls 6. So probability becomes 4 by 6. So obviously 4 by 6 means what? 2 by 3. Is it appearing? Okay. Similarly, can you tell me the probability of white chosen from B2? B2 means bag B2. That is can be write as white by B2 is equal. So now tell me how many white balls in bag B2? 3 are there. So total number of balls 7. So probability 3 by 7. So this is the information we have written, we have gathered. Now again take the question. We should find the probability of white, and that must be maybe bag B1 or maybe bag B2. So therefore probability of white from a bag is probability of white and in B1 or probability of white and in B2. So that is we should find. So probability of white and B1 means how can we represent in sets? White and means intersection B1. OR means plus. Probability of white in intersection B2. That we should find. So now according to conditional probability, P of A intersection B can be written as P of A by B into P of B. If it comes here, so P of A intersection B is equal to P of A by B into P of B. So like that, P of W intersection B can be written as P of B1 into P of W by B1. Okay. Next step. So I am writing P of W by B1 into P of B1 plus P of W by B2 into P of B2. In this way we can represent. So which is equal, what is P of probability of W by B1? 2 by 3 into probability of B1 1 by 2 plus probability of W by B2 3 by 7 into probability of B2 1 by 2. So simplifying this, actually in both can we take 1 by 2 common? Okay. You just simplify, you will get the answer. That's it. I am taking 1 by 2 common, remaining 2 by 3 plus 3 by 7 plus 3 by 7. I am simplifying this. So which is equal to 1 by 2 into here 7 3 LCM 21, 7 2 is 14, 3 3 is 9, 7 2 is 14, 3 3 is 9, 14 plus 9 23. So which is equal 23 by 2 into 21 42. So this is the answer. Got it? First to define conditional probability definition write down. For that 2 marks will be awarded. What is conditional probability? If the occurrence of A it is given that B has already happened, then P of A by B is conditional probability. So P of A by B is equal P of A intersection B by P of B. Similarly, P of B by A also we can write. Then next onwards, question. In the question, 2 bags are mentioned, white balls and black balls, total number of balls. This structure are written based on the given information. Now I am writing one by one. First of all, probability of B1, bag 1, that is 1 by 2, bag B2, that is 1 by 2, because of there are only 2 bags. So total number of bags 2, bag 1, 1 only, so 1 by 2. Total number of bags 2, bag B2 is only 1, so 1 by 2. In this also we can write. Next, probability of white chosen from B1. See here already bag B1 is happened, so probability of white. So in bag B1 there are total 6 balls and white balls 4 are there. So 4 by 6 is the probability, that is 2 by 3. Similarly, probability of W by B2. Now we should find the probability of white. So that may be any bag. So that's why I have written probability of white from A bag. A bag means what? Maybe probability of white ball in bag B1 or probability of white in bag B2. Okay, any doubt? So it can be represented in sets whenever and is, we can say at that time W intersection B1, and similarly R means plus. Next, probability of white and B2 means W intersection B2. Next, W intersection B1 means by using conditional probability, like A intersection B can be represented as P of A by B into P of B. So like that, P of W by B1, W by B1 into P of B1. Similarly, this also can be written, and substitute the information and do it, you will get the 23 by 42 is the answer. Okay, shall we go to next problem? Okay, one more same type of question, just do the homework. I just explain. There are 3 black and 4 white balls in a bag. In one bag, 4 black, 3 white balls in second bag, and a die is rolled and the first bag is selected if the die is shown of 1 or 3, and the second bag for the rest. Find the probability of drawing a black ball from the bag thus selected. So definition not asked, just given information in one bag. So one bag 3 black 4 white, 3 black 4 white. Next, in the second bag 4 black 3 white, 4 black 3 white. Okay, so 4 plus 3 7. So this is the given information. So here for bag 1, first bag, the probability is mentioned by using a die. So before in the previous question simply we have written probability of B1 is 1 by 2, but here so probability of B1 is nothing but if a die is thrown, actually there are 6 possibilities, 1, 2, 3, 4, 5, 6. So total 6. For B1 condition 1 or 3. So 1 or 3. How many are there? 2 numbers. So 2 favorable, total 6. Total number of. So 2 1 just is 1 by 3. And similarly probability of B2 means a die is rolled shown of 2, 4, 5, 6. How many are there? 4 are there. Why I am taking 2, 4, 5, 6? Because of second bag for the rest. For the rest means remaining, means other than 1 and 3. Means 2, 4, 5, 6. How many favorables? 4. 4 are there. 2, 4, 5, 6. By total number of possible outcomes 1, 2, 3, 4, 5, 6, 6. So by doing this 2 by 3. Okay na? So in this way probability of B1, probability of bag B2 we can do. Next, same as usually, here question is asking for which ball, black or white? Yes, black ball. So probability of black ball he is asking. So we should write probability of black chosen from bag B1. So black 3 are there from bag B1. So total 3 by 7 we get. So here it will becomes 3 by 7. Next, second condition also black chosen from bag B2, that is from B2 how many black balls? 4 are there. So total by 7, and substitute in this. So from here onwards substitute and do, the answer will be, what is the answer? 11 by 21. So 11 by 21 is the answer, you do it. Okay, shall we go to next problem? Okay, next 10th one. From here onwards, very simple problems. Easily we can get 7 marks. See, first see the question. If A, B, C are 3 newspapers, okay, A is a newspaper, B is one of the newspaper name, C, like that. From a city, okay, 20% population read paper A, 60% population read paper B, and 14% read paper C, 8% people read both A and B, 5% read both A and C, 4% read B and C, 2% read all 3 newspapers, means A, B, C. Then find the percentage of population who read the at least one newspaper, means A or B or C. So how can we do this problem? First I am writing given information. 3 newspaper from a city, 20% population read paper A. So given that, very simple, this is 20% read A. That means probability of newspaper A can be written as 20% means what? 20 by 100. Very simple, that's it. Similarly, 60% read B. That means probability of B. So we can write easily this information. So very simple problem this is. Next 14% read C. Read C. That means probability of C is 14 by 100. Next 8% people both A and B. 8% both A and B. That means probability of end means what? Intersection. A intersection B is 8 by 100. Next 8%, next 5% A and C. 5% A and C. So probability of A intersection C is 5%, means 5 by 100. Next what? 4% read B and C. 4% read B and C. That means probability of B intersection C is 4 by 100. Is it clear? Okay, you can note down. Next 2% read all 3 newspapers. All 3 means what? A and B and C. That means probability of A intersection B intersection C is 2 by 100. So total information is gathered. Now very simple. What is question? Find the percentage of population who read at least one newspaper. Means first I am going to find probability of population read at least one newspaper, at least one paper. So that is probability of A union B union C. In this probability we can denote this condition as P of A union B union C. So what is P of A union B union C? Actually P of A union B nothing but P of A plus P of B minus P of A intersection B. Similarly, P of A union B union C is equal to, okay, in the next problem I will tell you in the 4 marks how to prove that question also. So here this is a formula you must remember. Okay, now like additional theorem on probability, means P of A union B equal P of A plus P of B minus P of A B, like that. So there is one more formula, that is P of A union B union C is equal to P of A plus P of B plus P of C. 3 are there, and minus P of A intersection B. Okay, can we write? Minus P of B intersection C minus P of C intersection A or A intersection B, and finally plus P of A intersection B intersection C. Okay, each and every information is there, just substitute and simplify, we get the answer, that's it. Okay, P of A, probability of A is 20 by 100. So P of A means 20 by 100. Next plus P of B, that is 16 by 100. Next plus P of C. P of C means what? Probability of C 14 by 100. 14 by 100. Then minus P of A intersection B, that is 8 by 100. Next minus P of B intersection C. What is P of B intersection C? So here 4 by 100. Okay, next P of C intersection A intersection C both same, 5 by 100 minus 5 by 100. Next plus P of A intersection B intersection C, that is 2 by 100. So simplify this, we get the answer. So overall LCM is 100. First I am adding positive terms, directly we can add because denominators are same. So 20 plus 16, 36 plus 14, 40 plus 2, 42 positives minus negative numbers, 8, 4, 12, 5, 17. So 42 minus 17 means how much? What? 52 total? 30, oh sorry, 52 total. 52 minus 17 how much? 35? Yes, am I right? 35 by 100. Means 35 by 100 means in percentage means what? So therefore 35 by 100 means 35% percentage population read at least one newspaper. That is the answer. Is it very easy or not? So a general statement is applied probability and it is solved using probability. So this is the question. So let us take one more easy problem. We have only few questions. Okay, 11th question. This is also very simple. If one ticket is randomly selected from ticket numbers from 1 to 30, then find probability that the number on the ticket is multiple of 5 or 7. Second one, multiple of 3 or 5. I will tell you one question, you do the second one, okay? So here some ticket numbers are given. So given that, I am taking those ticket numbers as all possible outcomes, okay? So given that all possible outcomes. So what are those? Those are 1, 2, 3, 4, 5, so and so 30. How many are there total? So n of s I am considering 30. So total number of possible outcomes. Therefore number of all possible outcomes is equal to n of s is equal to 30. Possible outcomes is equal to n of s is equal to 30. Actually the general simple process probability starting stage problems these are. Okay, in this intermediate level, actually these are 10th class level. In 10th class also we can see this kind of problems. In intermediate level means especially additional theorem, Bayes theorem problems and conditional theorem, multiplication theorem, so and so. Some different problems are there. Okay, so why I am simple, just listen. Here first condition is multiple of 5 or 7. So first I am taking first condition probability of multiple of 5 or 7. So multiple of 5 or 7 means first we should find multiple of 5 probability, next multiple of 7 probability, next multiple of 5 and 7 also we should find. After finding these three we can find 5 or 7. So here also we use additional probability theorem. P of A union B is equal to formula. Okay, first for 5. So let A is event of getting multiple of 5 on ticket number. Actually we have ticket numbers 1, 2, 3, 4, 5, 6, so and so 30. So in that what are the 5 multiples? 5 multiples. 5 2 ja 10, 5 3 ja 15, 20, 25. These are the 5 multiples. So those are I am writing. So favorable outcomes to event A. I am taking multiple of A taken as A are 5, 10, 15, 20, 25, 30. Okay, up to 30 only. So how many are there? N of A consider as how many are there? 1, 2, 3, 4, 5, 6 are there. So then what is probability of this multiple of 5 only? So therefore probability of A is actually formula number of favorable outcomes. Here N of A by total number of possible outcomes. N of S A is how many? 6 by 30. Just keep it as it is. Okay. Next second event. So let B is an event of getting getting multiples of 7, same, getting multiples of 7, okay, multiples of 7 on ticket number. So what are the multiples of 7? 7 tables, 7, 7 2 ja 14, 7 3 ja 21, 7 4 ja 28. Okay, these only. How many are there? 1, 2, 3, 4. So this we can treat as n of b because of event b is taken. So for this b, what is probability of b? Formula is favorable outcomes to b, that is n of b, by total number of possible outcomes, total 30. So becomes 4 by 30. We got it, p of a and p of b. So can we get a common multiple of 5 and 7? Okay. Common multiple means multiple of 5 and 7. So therefore the probability of A intersection B I am finding. Can we get A intersection B? Common elements in A and B. So here 5, 10, 15, 20, 25, 30. Here in B 7, 4. There are no common elements. Okay. So therefore probability of common multiples of A and B is P of A intersection B. How many are there? These are, that implies n of A intersection B is 0. So 0 by 30 means 0. So therefore now solution, probability of multiple of 5 or 7. Therefore probability of multiple of 5 or 7 is P of A union B. P of A union B means what? P of A plus P of B minus P of A intersection B. This is the formula. What is probability of A here? 6 by 30. Very good. Plus probability of B 4 by 30 minus probability of A intersection B 0 by 30 or 0. So now do that one. Denominator is same, 30 is equal. Next to numerator 6 plus 4. How much? 10 by 30 means 1 by 3. So this is the answer for first question, multiple of 5 or 7. Similarly do for second question, multiple of 3 or 5. So you will get to first write multiple of 3 means 3, 6, 9, okay, 12, so and so, and write the probability. Next similarly for 5, and next to common elements here you will get to, I think 15 and 30, 2 numbers you will get. Okay, you do it. I will tell you the answer. Answer is 7 by 15 for second question. Okay. And next 12th one. If a box containing 15 bulbs, in that 5 are defective, if 5 balls are selected randomly, find the probability of none of them is defective, one of them is defective, at least one of them is defective. So 3 questions asking. So box containing how many bulbs? Total 15 bulbs. So given that total number of balls, how many are there? 15. So in that how many are defective? 5. So number of defective bulbs. Defective. How many are there? 5. That means number of non-defective bulbs, how many are there? How many? Tell me. 10 are there. Yes, out of 15, 5 are defective, 10 are non-defective. Okay, what is question? Suppose 5 balls are selected randomly, then what is probability of so and so? Okay, 5 are selected. So out of total number of possible ways, possible outcomes, means out select 5 out of 15. So this is actually total number of possible outcomes without any restrictions. How many are there? Select 5 out of 15 means what? 15C 5. In permutation combinations we have done many problems in this way. So this we can consider as n of s, that is 15C5. So total number of possible means in every question this will be the denominator. Now take the one by one question. So first question, none of them is defective. None of them is defective. So first I am writing, let capital A be the event of getting none of them is defective. That means actually none of defective bulbs, there are 10 bulbs. So we have to choose only 5 bulbs. Okay, none of defective bulbs, 10 are there. If we select 5 bulbs, those 5 if must be non-defective, then 5 must be taken from 10 non-defective. Am I right? Okay, is it clear? We should get 5 selective. 5 must be non-defective. 5 must be non-defective means those can be taken from 10 non-defective bulbs. In how many ways it can be done? 5 out of 10 no means 10C. Yes, tell me, 10C 5. Okay, got it, numerator. Therefore probability of none of them is defective, that is taken as A. That's why probability of A is formula n of A by n of S. So that is 10C5 by 15C5. This is the first question answer. Very simple, that's it. Just we should understand the concept, that's all. Second one of them is defective. We should select 5 bulbs. Okay, is it clear? In that 5, one of them is defective. So remaining 4, actually we should choose 5 bulbs. In that 5, one is defective. So one will be taken from defective means from 5. So 5C1, and remaining 4 can be taken from non-defective. So here 10 are there non-defective. In this 10, 4 non-defective can be chosen. Okay. So I am writing concept. So let some capital B the event of getting one of them is defective. So that implies n of B, one of them is defective means 1 from defective, remaining 4 from non-defective. 1 from defective means 5C1 into remaining 4 from non-defective 10C4. Yes. So here into I am writing. Why? In permutation combinations we have a statement. If a work done in m ways and another work done in n ways, total work can be done in m into n ways. Using that concept, 5C1 into 10C4. So now what is the probability? So probability of B is n of B by n of S. So that is 5C1 into 10C4 by 15C5 is the answer. Next, last one, third one. What is third one? At least one of them is defective. So let C is the event of getting at least one of them is defective. One of them is defective means maybe 1 are defect, or 2 are defect, or maybe 3 defect, or maybe 4 defect, or maybe all 5 defect. So we should do probability for 1 defect, 2 defectives, or 3 defectives, or 4 or 5. Instead of that doing all, we just simply do the probability is 1 minus probability of defective. Okay na? Because of all defective, one of them is at least defective. Both are what kind of complementary events. So we can take sum of those event and complementary event probability is 1. So that's why we can write 1 minus probability of defective. So that is equal 1 minus probability of defective what? Probability of, sorry, none of them is defective. Probability of none of them is defective is 10C5 by 15C5. So this is the answer. Okay, we just have one more question. So that is important question. In this all questions, newspaper A, B, C, that is very most important, and conditional probability important. So and more important is theorems, state and probability, additional theorem and multiplications. So these are the probability long questions, and one more question is there, 13th question. We can complete all long questions. Next level, in the next part we can see 4 marks questions. Okay friends, I think last 7 marks question, 13th one. 2 persons A and B rolling a die on the condition that the person who get 3 will win the game. 2 persons are rolling die. So there is a condition that suppose who get 3, those person will win the game. That's it. That is the game. Okay. Throwing a die. If I get 3, I am the winner. If I do not get 3, I will take another chance after taking another person. So like that, the 2 persons are playing a game by throwing a die. Okay, if capital A starts the game, then find the probability of A and probability of B respectively to win the game. So see here, probability of A and B, not probability of A and B. Here question is probability of A and B respectively, means we should find the probability of A and another question probability of B. 2 questions are given here separately. So how can we find? First of all, what is the condition here? What is the event here? What is the random experiment? Die. So here die is thrown. For die, what are the possible outcomes? Possible outcomes 1, 2, 3, 4, 5, 6. Total 6 are there. Total number of possible outcomes 6 are there. Here who get the 3, those person will win the match. That means suppose some P is taken, P taken as a probability of win the game. Win the game means if you want to win, 3 must be happened. How many 3s are there? Only 1 is there. So 1 by total 6. And similarly Q. Q also I am taking probability not win or lose the game. Not win or lose the game. So that will be, if you get other than 3, means 1, 2, 4, 5, 6. These 5 if you happen, that means you are lost the game. If you get 3, you are the winner. If you do not get 3, you are the loser. So P means win, Q means loss. Okay, some small condition this is. Now I am taking question. Probability of A I am going to find first of all. Probability of A. If A has to win, then he may win in the first level. In the starting stage only he can win. Or otherwise, if he lose, means if he does not get 3, then B will take chance. So here we are thinking for A. So to A winner, B also should lose the game. So A lose, B lose, A win. That means in first condition only he may get win, or in a third condition he will get chance, or in fifth stage. Okay, first A will start game. Suppose I am A, I throw the die. If I get 3, I am the winner. Suppose I do not get 3, then B will take chance. B also suppose he does not get, then again third position again I will get. If I get in the third position, I am the winner. Otherwise R means plus. If I third time also loss, then B will take chance. B also should get loss. Then fifth I will get chance. Okay, now why I am taking only for A? First I am finding for A. Similarly I will do for second question. So here win means winner probability P, lose means Q. How many Qs? 4 Qs and P plus so and so. In this way the game will be going on. So probability of A equal to P plus P into Q square plus P into Q power 4 plus so and so. So we just solve this information. P is common, 1 plus q square plus q power 4 plus so and so. Okay, how can we simplify this? P means as it is write down. Here this is in the geometric progression. If you observe, second term by first term, nothing but q square. Third term by second square, q power 4 by q square means q square only. So common ratio we get q square. Okay, this is in geometric progression. So sum of infinity terms formula, sum of S infinity formula in geometric progression is a by 1 minus r. Do you remember this formula? Okay, so we have to remember this geometric progression. If first term is here, first term a is 1, common ratio means second term by first one or third term by second term or fourth term by third term, you will get common ratio. Here I am getting q square. So we can say this is a geometric progression. In this geometric progression, sum of all infinite terms is a by 1 minus r formula. So a means what here? First term 1 by 1 minus r means what here? Q square. So this is the formula. So 1 by 1 minus q square we are getting. So which is called, now substitute p means what? That one also write down in the rougher, in the side. You must write down that one also. Now p means what? 1 by 6. 1 minus 1 by q means what? 5 by 6. 5 by 6 square. Simplifying we can get the answer. 1 minus 5 square 25 by 6 square 36. 1 by 6 into 36 1 ja 36 minus 25. How much? 36 minus 25. 11 11 by 36. So 1 by 6 into, here denominator comes to reciprocal, you get 36 by 11. 6 1 ja 6 6 ja. So 6 by 11 is probability of A. So winning of A is 6 by 11. That's it. Sir, how to do the second question? Very simple. There are only 2 persons are playing game. So probability of first person and probability of second person must be is equal to 1, because of sum of probabilities is 1. Here what are the probabilities? One is probability of A, one is probability of B. Only 2 probabilities are there. So probability of A plus probability of B is equal to 1. In next chapter random variables, you can see this statement, sum of all probabilities 1. Okay, we have done many problems. So for second one is probability of B. So that is 1 minus probability of A. So that is 1 minus 6 by 11. So that is 11 1 ja 11 minus 6, 5 by 11. This is the answer. Okay friends, sometimes in this few questions may ask for 4 marks also, no problem. Okay, especially for 7 marks important, very important means state and prove, additional theorem on probability, multiplication theorem on probability and Bayes theorem on probability, the problems based on Bayes theorem and remaining today's part questions. So these are all important, and who are writing the exam for 2020-21, they are no need to solve or no need to learn Bayes theorem problems. Okay, and of course some few problems we can expect in 4 marks also, like ABC or newspaper, those type of questions, and now honors, then after also some problems are there, those also we can expect for 4 marks also. So first give the preference for first part 1 and part 2, then these questions, and we can get the score. Okay friends, are you understand clear? If you have any doubts, please put in comment, I will try to give reply. And also please like if you are interested in our classes, and also please subscribe, click bell button and share with your friends. Thank you. In the next part we will discuss 4 marks questions. Okay.